It wasn't me, I didn't do it. Let me show you how we got here. It took a couple of days of taking this whole thing apart and flipping it over to see what's on the inside. Stand by.
I took a whole bunch of pictures as I was taking this apart. I'm just going to flip through them very quickly. If there's anything of particular interest, I'll pause and say something at that point. One of the main reasons I took all the pictures was so I know how it goes back together later. The bellows design is interesting. Some of those plastic pieces are cracked. If I need to replace them, I can have them laser cut from Send Cut Send. Here's our first look at the servos. I really like machines that have belts. They are way more compact than the machines that have a direct coupling. The servo themselves are brushed DC servos. This machine has a serial number of 19, so it must be a super early machine for this company. I don't know if it was serial number 19 for just this model or the 19th machine they ever made. But looking at their site now, their new designs look quite improved over this. But even this looks like a nice design to me. I know from my day job, when you design things, every time you make a new version, you always try to make it better than the last version. I was surprised to see only 2 mounting screws are used for each servo. It looks like the reason for that is because they used a round servo body and you just can't get the other 2 screws in there. I think the slots are so long, maybe they had an option for a square body servo, in which case the 4 mounting screws would have been at the corners of the flange. So I'll try to reuse these servos, and if it becomes more difficult than it's worth, I'll just put in NEMA 23 servos with a square flange, and hopefully those slots will line up. That's to be determined later. This looks like some sort of braking resistor, is my guess. I was looking for a way to tilt this machine to get to the bottom of it, and all the axes had the linear rails protruding from the body of the machine, and I didn't want to rest the machine on the linear rails. So on the y-axis, they have this plate here that is structural. Here's the back side of it, and it looks like that's specifically what that purpose is for. So you can rest the machine on its side without damaging any of the linear rails. I was trying to disconnect these wires from the spindle so I can disconnect the spindle from the machine, and I just couldn't do it, so I decided to put the spindle back together. I finally have the machine to a point where I can tilt it on its side and see what's on the bottom, and the spindle just got in the way. It was so heavy and the wire wasn't long enough. I should have left the spindle on and then tipped it over. The structural support they added, you can see here it's functioning to keep the linear rails protected while it's tipped over.
I don't know if this machine came with a box that's missing. I kind of think most of the guts are in here as far as the power supplies and the servo drivers. So I've been trying for a couple of days to get this apart far enough to get to the bottom of this because it's so heavy to handle by myself. All right. Well, it's got a lot of stuff in there. Now the question is, do I rip all this out and start from scratch, or do I keep any of it? Looks like a couple of power supplies, relay, wiring, and this is the brains, the computer. So probably to interface with this, it's going to be, I don't know if I'll be able to do it with anything off the shelf. Looks like there's relays here.
This custom PCB, it has all the servo drivers built into it and the relays, and it might even have the pulse generation. I don't know if that was done on this board or through the external PC when it was connected.
This whole time I couldn't disconnect this wire and this wire. There's no connection up here, and I didn't want to take this apart to do it. It was too much work. And you saw how much I struggled tipping this because of the spindle. So now I'm going to trace all those wires over here, find out which ones are those, and pull them off so I can pull the spindle off. And then I'll have to take an inventory of all this stuff down here and decide what's worth keeping. I know the power supplies are good, but this is going to be the biggest hurdle. So either strip everything out and start from scratch, or try to interface into this computer. So if you guys have any ideas, let me know. Let me see if I can get a close-up of what that is. It says Levil M10, so it looks like it's their own proprietary board. So there's no way I'm going to be able to interface with that, I don't think. I'd have to buy their software and buy their stuff. And actually, I contacted them, and they said they don't even support this control anymore. They said I can upgrade to a Fanuc control. But so I'll probably replace this with whole thing with a board from UC CNC. They're only $150 or $200. I think trying to figure out all these wires and all this stuff up here, you know, I'm sure it was good originally, but now to trace all that, it's just going to be probably more trouble than it's worth. I do like how they integrated all the electronics into the product. It makes it pretty nice, and it looks like everything is really clean down here. So all the housing material kept it clean. And also, it looks like my granite epoxy design, I'm probably way overbuilding it. I mean, this here, it looks like C-channel aluminum, but the wall thickness, I can feel it. It's about 3/16 of an inch thick. What I was doing on mine is 1/2 inch thick wall thickness filled with epoxy granite. The heart of this machine is this aluminum extrusion, which is about it's probably millimeters, probably 30 millimeters or 1.25 inches. Now I know what's on the bottom, so now I'm going to strip everything out and then clean it up mechanically and figure out what I'm going to do from a control standpoint. Well, I killed the machine. And now I'm going to bring it back to life. Thanks very much for watching. I'll catch you guys on the next episode.